Storage Engine Specific Optimizations Part 1 of 2. In this nugget, we begin to turn the tide a little bit from optimizations that deal with MySQL querying and database level stuff more to an architectural standpoint closer to the file system. Here we look at the storage engines in particular, focusing on the two most popular ones, MyISOM and InnoDB. This nugget contains some really nice secrets that you can apply in your practical environments post-haste. Let's get to work. We're going to begin this nugget with MyISOM, which, as we all know, is the default storage engine in MySQL 5.x. The question of the day is, what are some tips and tricks for keeping our tables that rely upon the MyISOM storage engine running as quickly, efficiently, and powerfully as possible? Well, the first suggestion from the MySQL team is to do everything you can to keep the MySQL Query Optimizer component current and up to date. After all, if the Query Optimizer starts to fall out of date or stale, then it stands to reason that query performance is going to suffer. It's going to take longer to give query results back to your users, and your users are going to be unhappy campers. Of course, the answer to this is in the following two commands, analyze table and optimize table. Now, there's some subtle differences between these two commands that you need to be aware of for your certification exam and for your practical application in the real world. First of all, we have analyze table. Now, specifically with MyISOM, what we can do is run analyze table against MyISOM tables, and what these do, by the way, both of these are shell commands, not commands that you'd run from within the MySQL client application. Analyze table, in a nutshell, is used to update your index statistics. The point to this is, especially for tables that are frequently modified, you'll want to periodically run this on a schedule. And by this, of course, I mean the analyze table statement against those frequently modified MyISOM tables to make sure that your index stats remain up to date. Now, the optimize table command is different from analyze table inasmuch it will also defragment your data file. Tables can become, and when I say tables, I'm referring now to MyISOM tables, can slow down over time because as updates and deletes happen, especially with variable length data type columns like blob, text, varchar, and so on, and the table is periodically reorganizing contents, just like file system data can become fragmented, so can your MyISOM MYD data files. Optimize table is kind of like a MyISOM disk defragmenter for your MyISOM data files. Now check this out. This is a pretty neat tip that you may not be aware of. Optimize table includes analyze table functionality. Therefore, if you already plan on running optimize table periodically against your MyISOM table files, you do not need to run analyze table. It's redundant. Optimize table will take care of both defragmenting the data file as well as updating index stats. Keep that straight for your upcoming exam, all right? Another really neat optimization strategy for MyISOM is for you to consider full text indexing. A little bit earlier in this nugget series, when we talked a little bit more, or at least initially, about storage engines, we talked about MyISOM and InnoDB, and I mentioned that the trade-off chiefly between those two primary storage engines is that the InnoDB on one side has transactional support as its chief selling point, while MyISOM has essentially speed and stability and simplicity as its chief selling point. Well, I forgot to mention one more advantage that MyISOM has, and that is, of all of the storage engines that come bundled and available to you in box with MySQL Server, only MyISOM supports full text indexing. Now, full text indexing may be of primary importance to you, for instance, if your web application involves, say, a full text capable search engine. You may, for instance, develop a web application for, let's say, a human resources department where internally you want to be able to search all employee resumes for a certain text field. Or maybe you run a MySQL web application for a small liberal arts college, maybe the applications or admissions department, and you're storing everyone's admissions essays, and you want to be able to perform full text searches on those essays. These are all cases where it's perfectly appropriate and necessary, actually, for you to do indexing not just on a small text string, but on a wider amount of data. In this case, you would need to do a full text index scenario. Now, besides the fact that we're limited in MySQL to the MyISOM storage engine for that particular table on which you're doing full text indexing on a column, but you're also limited somewhat to the type of data type on that column where full text indexing is relevant. Basically, you cannot attach a full text index on a binary string data type. Remember, binary deals with non-plain text or non-traditional alphanumeric textual data. Therefore, if you were storing, in the case of the liberal arts college example I gave you, if you were storing the prospective students' essays in native, let's say, Microsoft Word document format, and you were actually storing the document files natively in binary format, well, you wouldn't be able to full text index those, unfortunately. You would have to extract the data out of those files and store them in a column in a MyISOM table using a traditional non-binary string format. In other words, something like char, varchar, or text. Now, yes, that is limiting. Potentially, that's a deal breaker for you. You might be coming from another system that has a more robust full text indexing solution like Oracle or Microsoft SQL Server, and you're saying, what's up? However, this is just how it is, friends. That's just how it is. Having understood these limitations, let me show you the code. Now, you don't have to know the deep ins and outs here. I'm going above and beyond what you need to know for the DBA2 exam. That's just because I'm that kind of guy. And also, some of you may be interested in pursuing the additional certifications offered by the MySQL folks. For instance, the Certified MySQL Developer. In that case, you'll certainly need to know the great details on setting up full text indexing. It's really not difficult, though. Let me show it to you. First of all, you would, for instance, create a table, or if you already have a table, you would run alter table, and you would attach a full text index to a string column, as long as it's not binary, like I said. And by binary, we're talking about a data type like binary, var binary, or blob. All right, in this example, though, we're creating a table called test with one column called product using varchar 50, and here we're attaching an index using the full text keyword. This creates, of course, a full text index on the product column. Now, there are several different syntaxes you could use here. There's a standalone DDL statement called create full text index. We could also run alter table once we created this test table, saying using the add full text clause. I mean, there are tons of different ways to go about it. This is just one example. And then once we've done this, all you'd have to do to make use of the full text index is, for instance, run a select statement against the table, and you notice we have a couple clauses here. In our where clause, we can invoke this match function where we pass in our search column or search columns. Of course, the match and the search column is going to map back to our product column in our test table. And then the against clause here is going to pass in a string that will be our search string. So this, of course, this query is going to be the basis of a stored procedure that you would link to form fields in your web application. So in your web form, you would in all likelihood have a small search text box that would be where your users would put their search string, and then they would click go, and whatever the users put in the search box would be substituted or passed into the against field here, and so on. I hope you have the general idea. Bottom line is, full text indexing is one of many neat things we can do to optimize and extend and enhance the performance of MyISOM tables. Now let's have a look at MyISOM maximum row count. This part of the nugget reminds me a little bit of IP addressing, and I hope that doesn't scare you. It tends to freak out students I've had in the past and colleagues I've worked with in the IT industry, but I hope you don't fall into that category. Believe me, we don't need to get into the mathematics here. Here's the situation with MyISOM maximum row count, friends. Nutshell summary is, prior to MySQL version 5, MyISOM kept track of rows in a table by using 4-byte long pointers. Now the bottom line is, think of a table and where each row is and where each column in each row is. Think of it logically now as a grid, and each grid having a particular ID. MyISOM or MySQL needing to be able to identify or point to each row and each column with a discrete location. Hence, we have the idea of the pointer. Now, due to various architectural limitations, we have a maximum number of pointers that MySQL can work with depending upon the storage engine in use. And as I just told you, prior to MySQL 5, it had a maximum number of pointers that it could map to of 4 bytes, which actually turns into, if you do the math, with 1 byte being 8 bits, it's 2 to the 32nd. So the maximum grid or map is about 4 billion, which estimates out to about 4 gigabytes worth of a table. So without all the math, getting hung up in all the math, prior to MySQL 5, you had a maximum table size of 4 gigs simply because MySQL couldn't track any more pointers. It just literally, any more data would fall off the grid. Now, as of MySQL 5, we moved to a 6-byte pointer. Now, 8 times 6 is 48. So we now have a maximum field or grid size of 2 to the 48th power. And if you do the math, that turns out to be a tremendously large number. So the maximum table size as of MySQL 5 has jumped to 256 terabytes. I think that should keep most MySQL administrators pretty satisfied for at least the next couple years. Now, that having been said, you can provide what are called server hints to save disk space and to increase processor efficiency. And what we're doing here is kind of informing MySQL in advance approximately how many rows the table is going to store. This is in a way, analogously, for those of you who come from a Microsoft SQL Server background, a way to, if you've done this before, in SQL Server, when you create a data file, you can specify a maximum size of that data file and kind of put a cap on it, such that the file can grow and grow and grow, and when it reaches that maximum cap, it doesn't grow anymore, and any attempts to continue to grow the file fail. And it's the same idea here. But it also has the advantage of, now that MySQL has some ballpark idea of the maximum row size or maximum row count of the table, it's able to allocate space more efficiently and just adjust itself accordingly, better than if it were just kind of free and easy. You see what I'm saying? And the way to do this is really quite easy. You could just specify the max rows parameter in your create table statement. So in this first bit of code, create table test, and then you do your column declarations, you close out your column declarations, and then in the end where you would specify your collation, your engine statement, and etc., you would say max underscore rows equals, I left out an equals, and then the number of rows. Of course, you wouldn't want to set that too low, but also note that even though once you do hit this maximum row count, you would not be able to put any more rows in. It's true. Any user who tries to add more data past this limit would receive an error. That doesn't prevent any further inserts as long as you adjust the value. All you'd have to do to fix this is run an alter table and set a new max rows value and then all is ducky again. You're back in business. You can continue to add new data. To see what your max rows value is at any point in time, you can use this really helpful command that I've already showed you a little bit earlier in the nugget, show table status. In fact, we're going to use this a lot in this particular nugget. It's helpful for maximum row count, and it's also helpful for fixed versus variable row size, which we're going to take a look at next. MyISOM row storage formats. The final aspect of MyISOM optimization we'll look at before moving to InnoDB and then our demo is this notion of row storage formats. There's actually 3 different formats. I've only covered 2 on the whiteboard. However, we'll discuss the third now and cover the third in the upcoming demo. Now then, first let me give you a heads up. There's a great article in the MySQL reference manual that covers the MyISOM table storage formats. You might want to check it out for a detailed exposition of what I'm teaching you now. However, I'm giving you all the need-to-know info, no question about it. Now then, the introduction. MySQL, when you're using MyISOM, will choose automatically what it thinks is the appropriate storage format for your table rows depending upon your data type for your columns. If you have not selected any variable length columns, and by your variable length, we're talking about your vars, right? Your varchar, your var binary, your blob, your text, your stuff that can be expanded or contracted depending upon whether or not you've got data there or not, for instance. A lot of folks like varchar because they like the fact that you traditionally save data with a varchar row as opposed to a fixed length data type like char, where if you do a char 10, you're always reserving those 10 bytes, and so on. Well, there's some pluses and minuses to that approach, as we've already talked about earlier in this Nugget series. I'm going to take this whiteboard and give you the skinny really quickly. Bottom line is, if you've done a MyISOM table where all of your columns are of the fixed length or static variety, then you'll find if you run a show table status that MySQL will choose the static or fixed length table format, where every row is the exact same size. The fixed length is actually preferable dollars to donuts to the dynamic length. You wind up getting more efficient data lookups at the expense of bigger tables. Now, that's really the trade-off. However, in 2009, when we talked about this earlier in the course, disk cost has never been lower. So really, most DBAs, myself certainly included, tend to want to increase performance and not be as concerned with spending a little bit more on the disk cost. You see what I'm saying? So by padding out and fixing our row lengths to the same size, we're decreasing fragmentation, we're increasing our data lookup efficiency at the expense of, by padding out those rows, creating some slightly bigger tables. Limitation: the table cannot use the text or blob columns. You might also be asking yourself, all right, well, am I hosed then in terms of if I want to have a MyISOM table that does use some variable length fields? Like if I want to use varchar, can I use fixed length row storage format anyway? And here's the great news, friends. You can. Isn't that great? It's true that MySQL will automatically give you the fixed length row storage if you use nothing but fixed length fields. But I'll show you in the demo you can override that with your DDL statements. Stay tuned for that. Now, the other side of the coin is for those of you who are parsimonious. Maybe you're running on older hardware and you've got seriously limited budgets. Dynamic length is chosen by default. Really, I would bet you $20, I'll make it $50 to stale, dried up cheese pizza that most of your MyISOM tables are dynamic length row storage, because MySQL will choose dynamic length storage whenever it sees variable length fields. And who doesn't use variable length fields nowadays unless they know any better? Here, your data rows are of variable size. This is going to slow down data retrieval for the same reason allowing null values slows data retrieval. It's going to give you space advantage, just as we discussed before, just like using varchar over char is going to give you a space advantage. However, the other side of that coin is the variable length fields contribute to heavy fragmentation. So if you're not on top of your maintenance schedule and running optimized table or other third-party utilities to address that fragmentation, you're not only dealing with slow data retrieval out of the box, but you're compounding that once the fragmentation level starts to take off. Please be aware of that. The other side of the coin is the InnoDB storage engine. Let's take a look at some quick summary suggestions for optimizing InnoDB. One somewhat surprising suggestion, at least it may be surprising, is to do periodic table rebuilds, literally to dump and reload InnoDB tables. Now, it might be surprising and shocking to you because you think, well, my InnoDB tables are 1 million plus rows. It's not a trivial operation for me to simply dump, in other words, back up, drop, and reload this table, especially if you're a 24/7 shop and have to rely upon scheduled downtime to do this kind of stuff. Nevertheless, that's the suggestion from the MySQL team. Another suggestion is to take advantage of the ACID properties of InnoDB. ACID, you might recall, is an acronym that defines fundamentally the principles of a transaction-safe relational database management system. In other words, a transaction being a unit of work that is A, atomic, C, consistent, I, isolated, and D, durable. Specifically, this recommendation asks that we group transactions for efficiency and control. What's neat about InnoDB is that we can use the start transaction and commit transaction statements to bundle one or more, statements, for lack of a better term, together to make sure that they execute as a batch, together 100%, either pass 100% and commit to the database, to the InnoDB tablespace file, or roll back. Actually, with save points, you can do partial commits, partial rollbacks. These are great advantages of the InnoDB storage engine. Yet another suggestion for optimizing InnoDB tables is to use varchar columns instead of char, which, in a complete turnaround from what we learned about with MyISOM, involve less disk space to use and less processor and memory I/O. Can you believe it? Finally, we have the suggestion to use short primary keys. This is a good suggestion anyway. We want to keep our keys as narrow as possible, certainly avoiding the problem of compound keys. So I shouldn't use the term problem, but the possible complexity of breaking out a primary key into more than one column. All right, time for our demo. In this demonstration, we're going to work with optimizing storage engines, paying particular attention to the MyISOM storage engine. Frankly, InnoDB is largely optimized right out of the box. So, as I said, in this particular demo, we'll focus our efforts chiefly on some of the neat tips and tricks we covered with MyISOM. Let's get rocking. In this demo, we're working with MyISOM specific optimizations. We're obviously on our Linux server now, LinNugget 1, and you also obviously see I've logged into MySQL as the root user. We're going to use the world database, and we'll begin by working with one of the tips and tricks we covered. This one is dealing with row format, fixed row versus variable length row formats. Why don't we start by creating a table? I'll call this T1 with a simple column, and this guy is going to have a fixed length char2 data type. We'll then show table status and see what we've got going on. And as promised, you'll notice that the row format comes back as fixed. This is as expected because the column data type is fixed in length. Therefore, it should stand to reason that if we create another table, I'll call this T2, and I'll create a column with a variable length column. I'll use varchar 10. We'll run show table status on it now, and you see that the row format is dynamic. All right. Okay, so to finish this little ditty out, let's create a third table, or actually we could run alter table, but I'm just going to do it this way to show you different ways to go. I'm going to create a third table, T3, and again I'm going to use a variable length column data type. And check this out. After my column declarations, I'm going to throw in row underscore format equals fixed. Remember, fixed is where we expand our table size a little because we're forcing all of our rows to be the same size, but we're also greatly reducing fragmentation and we're increasing query processing speed. Therefore, row format equals fixed is a really nice tweak for your MyISOM tables. You also notice that we're applying the fixed row format even though we have a variable width column. And first of all, let's see if this works. Aha, it did. Show table status comes back, fixed. Rock and roll. Next thing I'm going to show you is the third type of row storage, and that is compressed. There's fixed and variable length row formats, and then compressed is the third. I told you I was going to teach you this back in the whiteboard, and I plumb forgot. Fortunately, I remember now that we're in the demo portion of this course. The deal with compressed MyISOM tables, friends, is they're great at saving space, they're great at archiving data. The Achilles heel with compressed MyISOM tables is simply that they are read-only, all right? So if you have some MyISOM data that you know you're not going to need to modify, that's just archival, it really behooves you, in my opinion, to compress them. And it's easy to do. You do it from the shell, and why don't we just go ahead and do it right now, as a matter of fact, instead of me talking about it. So we'll just -Q to get out of MySQL. I'm going to become root here, so that I have full access to my data dir, and I'm going to move on over to varlib mysql world to get into the world database where all my MYD and MYI files live. And the utility that we use to do the packing is MyISOM pack. And you just simply run. You could sudo this, or I've actually become root as you see here. I'm on Linux. You run MyISOM pack space, and then you could do it against multiple data files if you just want to do a space-separated list like this. I'm just going to go against the city table for now. Tells us compressing city.myd, and it's given us a 70.94% compression ratio. And then it tells us to remember to run MyISOM check RQ on compressed tables. Now, what does that mean? Well, what MyISOM check does with the RQ switch is it will rebuild any indexes if we run it against our index. Now, do we have an index for city? We sure do. So what I'm going to do now is run MyISOM chk -rq city.myi. In order to really kick this off, I'm going to reboot the server and then log back in. Now, what I should have done before compression, although it's not that big of a deal, is run show table status before running the compression and then run it again afterwards. Not that big of a deal. Let me use world, and let me just show you the fields that we would have looked at. Show table status like city. We'd want to look at the data length and the index length columns. These are the ones that we would look at to see them go down before and after packing the file. Now, to make sure this bad boy is compressed, let's just run a select splat from city, limit 5 just to see what's there. And I'm going to run a quick update, or at least attempt an update against the city table. All right, so I'm saying set the name column equals to Timmy, where country code equals AFG. Obviously, it's a bogus update, but let's see what happens. Gives us the expected result. Table city is read-only. And by the way, in case you were wondering, let me open up a tab. The way that you would unpack a compressed table is to navigate back to where the table exists. In this case, the world subdirectory in the data dir. You would just run MyISOM check with the unpack flag and then the table name. So if we did need to get read-write access to the table, it'd be really easy to do. We would simply run MyISOM check again. Now, you might need to stop the server, worst case scenario. You'll note that in my example, I did not need to stop the server. However, in a production environment, I might have had users actively using the world sample database, and there may have been locks out that would have prevented me from doing that compressed operation. So your mileage may vary, remember. Let's complete this demo with a brief tutorial on creating a full text index in the MyISOM storage engine. What we're going to focus on is the country table in the World Sample Database. So to get a fix on the fields or columns in that particular table, we'll run describe against country. A lot of columns in here, a lot of columns indeed, using several different fixed and variable length data types. However, I've done some background research, and I believe that government form char 45 is our best candidate for a full text index. So let's just grab select name, government form, and I'll show you what I mean. You see that the government forms, some of them have fairly long names. Islamic Emirate, Constitutional Monarchy, Non-Metropolitan Territory of the Netherlands. Boy, say that 5 times quickly, right? Therefore, we're going to attach a full text index to the government form, which again uses the character data type, so it's certainly a legal field for us. Because this table is already created, now of course there's the question, does it use MyISOM? A couple different ways we can verify this. I'll run show create table country, and we see engine equals MyISOM, no problem there. I'm going to run alter table country, add full text. We can give an arbitrary name to the index. I'm going to call this gov_idx, and then we pass in the name of the column, government form, in parentheses. After a pause, very quick, query OK, 239 rows affected, so on. So the index has been created. Now, of course, your mileage may vary. If you have a humongous table, it's going to take a while to grind out a full text index. For our part, though, we can immediately begin using the index by querying directly against some of the data. So what we'll do is let's select name, government form, from country, and then here's where it gets interesting, where match is on the government form column, and then against is our search text. And I'm going to search against monarchy. Now you'll remember, I don't know if I still have it in my screen buffer here. Here it is. That constitutional monarchy is a legitimate government form, but you see that monarchy is actually not part of the lead text in the column. Now I'm going to run the search against monarchy specifically because this should demonstrate that our full text index is actually indexing the entire contents of all text in this column. Scroll back down to the bottom and let's see what we get. Looks good. We come back with a 43-row set and we get returns on monarchy alone, monarchy with other data, and of course constitutional monarchy. That in a nutshell, my friends, is how full text indexing is implemented in MySQL at base. Storage Engine Specific Optimization Part 1 of 2 Review. In this nugget, I introduced you to some storage engine specific optimization tips and tricks. We first looked at MyISOM, the default storage engine in MySQL Server. I hope you have some really neat ideas that you can take into your production and development environments and begin to apply immediately. We then looked at InnoDB. There were fewer suggestions from the MySQL team regarding the storage engine, to be sure. However, InnoDB really is quite powerful on its own. There's really not all that much we need to do to it, especially when we compare it to MyISOM. However, hang on to your hats. We'll be dealing more with InnoDB throughout the remainder of this course. I hope that this has been informative for you, and I'd like to thank you for viewing.